Hello friends, our subject is mass transfer operation part 1 and chapter 1 is introduction of the mass transfer operation. Next, what are the contents of this lecture is first one is introduction of the mass transfer operation, second one is classification of the mass transfer operation based on the direct contact of two immiscible phases separated by membrane, direct contact of miscible phases, and use of the surface phenomenon. Now, what are the introduction part is what are chemical engineers generally concerned with the problem of changing the composition of the solution and mixture through methods not necessary involving the chemical reaction. Means if there is a no present of the chemical reaction, that doesn't mean there is no change in the composition, right? For example, if we are consider the filtration of the solid from a suspension in a liquid, the classification of a solid into a fraction of different particle size by screening, or the separation of the particles of the ground solid according to the density, means there the composition change is occur, but reaction is not present, right? So, in general term, operation involves changes in the composition of solutions. They are known as the mass transfer operation, right? Means change in the composition of the solution. That means the mass. It includes the mass transfer operation. These separations. Another on the other hand, if the operation involves the change in the composition of the solution, they are known as the mass, and it is thus which concern us here. The importance of this operation is profound. There is a scarcely and chemical processes which does not require preliminary purification of the raw materials or final separation of the products from byproducts, and these the mass transfer operation are usually used. One can perhaps the most readily develop an immediate appreciation of the part this separation play in a processing plant by observing the large number of the towers which bristle from the modern petroleum refinery, in each of which is a mass transfer frequently the major part of the cost of the separation processes. So this separation or the purification cost depend directly upon the ratio of the final concentration to the initial concentration of the separated substance. So we will measure the concentration of the final composition and the concentration of the initial composition. Based on this, the cost is also depend. If this separation or purification costs depend directly upon the ratio of final and large, right? So we consider the sulfuric acid example. Sulfuric acid is relatively low price product, in part because sulfur is found naturally in a relatively pure state. So we are having it is available at the low cost, right? Comparatively pure uranium is found in a nature. This is expensive because the low concentration is found in the nature. Sulfuric acid is found in the nature in a high amount. So the mass transfer operation are characterized by transfer of a substance through another on a molecular scale. For example, we are having a two example. First, water evaporates from the fuel. Is this a mass transfer operation or the pumping a liquid through a pipe? This is the mass transfer operation. So here the water evaporates from the pool, means diffusion occurs. So it is mass transfer operation. Now this separation or purification so based on this mass transfer operation, we are having a classification of the mass transfer operation. So basically four types of the mass transfer operation classification is four types. First one is direct contact of a two immiscible phases. Two phases have solid, liquid, gas. Means contact of the solid, 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 liquid, solid, gas, gas, solid, gas, liquid, gas, gas, right? So these are the total phases contact of the in the mass transfer operation in a two phase system. It is useful in a two. This categories is by far direct contact of the two immiscible phases. This category is by far the most important of all and includes the bulk of the mass transfer operation. Here we take advantage of the fact that in a two-phase system of several components at equilibrium with a few exceptions, the composition of the phases are different. The various components, in other words, are differently distributed between the phases. The separation thus afford leads the immediately to a pure substance because one of the phases at equilibrium contains only one constituent. For example, the equilibrium vapor is in contact with the liquid aqueous salt solution, contains no salt regardless of the concentration of the liquid. Similarly, the equilibrium solid in contact with such a liquid solution is either the eutectic pure water or pure salt, depending upon which side of the eutectic composition the liquid happens to be. Now, starting with the liquid solution, one can then obtain a complete separation by boiling off the water. Alternatively, pure salt or water can be produced by partially freezing the solution, or in principle at least both can be obtained uh, pure by complete solidification followed by mechanical separation of the eutectic mixture of the crystals. In this type of cases, when the two phases are first formed, they are immediately at their final equilibrium compositions, and the establishment of the equilibrium is not a time dependent process. Such separation, with one exception, are not normally considered to be among the mass transfer operation. Right? When the two phases are initially contacted, uh, 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 be of the equilibrium composition, the system may then attempts to reach equilibrium by relatively slow diffusive movement of the constituent, which transfer in a part between the phases in the process. Separations are therefore never complete, although as will shown they can be brought as a near completion as desired by appropriate manipulation. Means separation, we cannot say that 100% separation is there, right? So we can say that we have reached up to the desired point. Now, first one is liquid. So, if all the components of the system distributed between the phases at equilibrium, the operation is known as the fractional distillation. If the In this instance, the gas phase is created from the liquid by application of the heat, or conversely, the liquid is created from the gas by removal of heat. For example, if the liquid phase is a pure liquid containing for example, if the liquid solution of the acetic acid and water is partially vaporized by heating, it is found that the newly created vapor phase and the residual liquid both contain the acetic acid and water, but in proportion at equilibrium, which are different for the two phases and different from those in the original solution, right? So, both phases may be solutions, each containing, however, only one common component which distribute between the phases. For example, if a mixture of ammonia and air is contacted with the liquid water, a large portion of the ammonia but essentially no air will dissolve in the liquid, and this way the air ammonia mixture can be separated. The operation is known as the gas absorption. Third one is if the liquid phase is a pure liquid containing but one component while the gas contains two or more, the operation is known as the humidification or dehumidification based on the direction of the process. Second one is gas solid. Classification of the operation in this category according to the number of the components which appear in the two phases is again convenient. First one is fractional sublimation is the example of the gas solid, right? So, not all the components may be present in both phases. However, if a solid which is moistened with the volatile liquid is exposed to relatively dry gas, the liquid leaves the solid and diffused into the gas, an operation generally known as a drying and sometimes desorption also. means drying curve, that is represent as the desorption curve also, right? So the homely example of drying is drying laundry by exposure to the air, and there are many industrial counterparts such as drying lumber or the removal of the moisture from a wet filter cake by exposure to the dry gas. These are the example of the drying. If the diffusion takes place in the opposite direction, the operation is known as the adsorption also. As we have discussed, it is also based on the direction, it is humidification or dehumidification. Similarly, it is adsorption or desorption. Third one is liquid separation involving the contact of two insoluble liquid phases are known as the liquid extraction operations. A solution of acetic acid, a simple example we have considered, that is a laboratory procedure. If an acetone water solution is taken in a separately funnel with the carbon tetrachloride and the uh, liquids allowed to settle, and the large portion of the acetone will be found in the carbon tetrachloride rich phase, that is our extract part, and will thus have been separated from the water also. A small amount of the latter will have entered the water layer, but these effects are relatively minor, right? The another form of fractional extraction can be effected by producing two phases from the single phase solution by cooling the latter below its critical solution temperature, and this is known as such operation is known as the fractional extraction. A solution of acetic acid and acetone can be separated by adding it to the insoluble mixture of water and carbon tetrachloride also. These are the second example. After shaking and settling, both acetone and acetic acid will be found in both the phases, right? uh, Next one is liquid solid. When all the constituents are present in both the phase uh, at equilibrium, we have the operation of fractional crystallization. Perhaps the most interesting example of these are the special technique of zone refining used to obtain the ultra pure metals and semiconductors, and adductive crystallization, where a substance such as urea has a crystal lattice which will selectively entrap long straight chain molecules like the paraffin hydrocarbons, but will exclude the branch molecules, right? Most inter- so uh, where branch molecules, selective solution of the component from the solid mixture by a liquid solvent is also known as the leaching. So leaching is also example of this category. So, six one is a solid. Because of the extraordinary slow rates of the diffusion within the solid phase, there is a no industrial separation operation in this category. Similarly, in the gas, since very few exception all gases are completely soluble in each other, this category is not practically realized. So second classification is spaces separated by the membrane. So generally, these operations are used relatively infrequently, although they are rapidly increasing in the importance. The membranes operate in a different ways depending upon the nature of the separations to be made. In general, however, they serve to prevent intermingling of two miscible phase. They also prevent ordinary hydrodynamic flow, and movement of the substance through them is by diffusion. And they permit a component separation by selectively controlling the passage of the components from one side to the other. First one is gas phase. In a gaseous diffusion or effusion, the membrane is microporous. If a gas mixture whose components are of a different molecular weight is brought into contact with such a diaphragm, the various components of the gas pass through the pores at the rates depend upon the molecular weights. This leads to different composition on opposite sides of the membrane and consequent separation of the mixture. In this manner, large-scale separation of the isotopes of uranium can be done from the gaseous uranium hexafluoride is carried out, right? So second one is gas liquid. These are the permeation separation where, for example, a liquid solution of the alcohol and water is brought into contact with the suitable non-porous membrane. In such, the alcohol preferentially dissolves after passage through the membrane. The alcohol is vaporized on the far side. Third one is liquid liquid. The separation of the crystalline substance from a colloid by contact of their solution with the liquid solvent with an interviewing membrane permeable only to the solvent and the dissolved crystalline substance is known as the dialysis. So dialysis process is considered into this. For example, the aqueous beet sugar solution containing the undesired colloidal material are free two of the latter by contact with the water with an interviewing semi-permeable membrane. If an electromotive force is applied across the membrane to assist in the diffusion of charged particles, the operation is known as the electrodialysis. If the solution is separated from the pure solvent by a membrane which is permeable only to the solvent diffuses into the solution, an operation known as the osmosis. This is not a separation operation, of course, but by superimposing a pressure to oppose the osmotic pressure, the flow of solvent is reversed, and the solvent and the solution can be separated by the reverse osmosis. This is one of the process which may become important in the desalination of the seawater. Third classification is direct contact of the miscible phases. Because of the difficulty in maintaining the concentration gradient without mixing the fluid, the operation in this category are not generally considered practical industrially except in unusual circumstances. First process is thermal diffusion. Thermal diffusion involves the formation of concentration difference within a single liquid or a gaseous phase by imposition of the temperature gradient upon the fluid, thus making a separation of the component of the solution possible. If a condensable vapor such as steam is allowed to diffuse through a gas mixture, it will preferentially carry one of the components along with it, thus making a separation by the operation known as the sweep diffusion. If the two zones within the gas phase where the concentration are different are separated by a screen containing relatively large openings, the operation is called the atomolysis. If a gas mixture is subjected to a very rapid centrifugation, the components will be separated because of the slightly different forces acting on the various molecules owing to their different masses. The heavier molecules thus tend to accumulate at the periphery of the centrifuge. This method is also used for the separation of the uranium isotopes. Fourth classification is use of the surface phenomena. Substance which when dissolved in a liquid produce a solution of the lowered surface tension are known to concentrate in solution at the liquid surface by forming a form of large surfaces. By bubbling air through the solution and collecting the foam, the solute can be concentrated. In this manner the detergents have been separated from the water. For example, the operation is known as the foam separation. Direct and indirect operations. So the operations, depending upon the contact of the two immiscible phases, particularly can be further classified into two types. The direct operations produce the two phases from a single phase solution by addition or removal of heat. For example, fractional distillation, fractional crystallization, and the one form of the fractional extraction are of this type. Second one is the indirect operation involve the addition of the foreign substance and include the gas absorption, stripping ring, adsorption, drying, leaching, and liquid extraction, and certain types of the fractional crystallization. It is characteristic of the direct operation that the products are obtained directly. free of the added substance, and these operations are therefore sometimes favorable in the comparatively to the indirect operation. If the separated products are required relatively pure, the disadvantage of the indirect operation cured by the addition of the foreign substance are several. The removed substance is obtained as a solution, which in this case must in turn be separated, either to obtain the pure substance or the added substance for use. Means if we are adding third component into the solution, we need to separate it from the solution for the reuse or for the purification of this substance. Right? When the separated substance need not to be obtained pure, many of these disadvantages may disappear. For example, in ordinary drying, the water vapor air mixture is discarded since neither constituent need be recovered. In the production of hydrochloric acid by washing a hydrogen chloride containing gas with the water, the acid water solution is solid directly without the salt. uh, Acid water solution is directly solved without the separation of this solution. The next, the reference of this lecture is mass transfer operation Prebal book, and the lecture 2 contain that are the choices of separation methods of conducting mass transfer operations. Right. So please like, share, and subscribe this channel. Thank you.